Could the Francis Scott Key Bridge tragedy in Baltimore last year have been prevented? Engineers at Michigan State University think so. In fact, they've developed technology that incorporates AI called MIDAS. It's a two-part system where there's an actual sensor attached to the bridge, and then AI analyzes the data to help engineers learn about how this bridge behaves. It's the system that was first deployed right here in Michigan. Take a listen. Nazar joins us now. Thank you so much for being with us. First of all, tell us about this MIDAS system. Am I saying that right? Is it MIDAS? Is that how you would say it?
Exactly, yes. It's the MIDAS system.
Okay, tell us all about it and what does it specifically do?
All right, so if I start for the need on why we have developed MIDAS, right? So if you think back in the last couple of decades, we had a lot of big high-profile events of bridges that have collapsed due to either maintenance issues and also due to high impact events or high energy events, like an extreme event that happens on the bridge. So what's happening is that most of our infrastructure was built back in the 40s and after, like maybe all the way up to the 60s. And then we had a big gap where we did nothing. And we started looking at our infrastructure back in the 80s, trying to figure out ways on how to understand their behavior. The issue that we're having right now is we have a huge, extensive network. We have more than 620,000 bridges across the country, and we do not have baseline models for all of them. And we cannot do that. It is very expensive to try to fix all of them, and it's also very expensive to try to build baseline models to understand their behavior, right? A lot of the bridges were built a long time ago. We don't have an idea about what happened in the meantime. So those are the issues that we're trying to deal with. So what MIDAS does, it comes in, once you install it on a structure, is going to go and understand it over time. So it uses an AI system, an onboard AI systems on the sensors, that's going to listen continuously to the behavior of the structure and establish a baseline. So you don't need to have expensive models. You don't need to waste a lot of time to understand that behavior. The sensors themselves, they have an AI learning mechanism that allows them to understand the normal behavior of a bridge at its current condition. And from there is going to start identifying weaknesses or issues with the design or any other problems. Obviously, if there is no issue, it's not going to say anything. But we are looking at structures that have vulnerabilities. And the reason for that is we would be ready when something big happens. That's the idea. So the MIDAS will understand the behavior and will allow us to run different scenarios in case of an impact, in case of a fire, in case of an earthquake, a hurricane. And from there, we know exactly what would happen and we would prepare for it. So we're not surprised by an event like what happened, for example, in Maryland about a year ago. Once the impact happened, we realized that there are weaknesses into the structures that led to the total collapse. So if we had a system like that, monitoring over a certain number of years ahead of that big event, then we would know where to reinforce the structure and where to add redundancy, for example, so that when something big happens, we're ready. That's the key here. MIDAS is a low-cost system that's going to understand structured behavior completely autonomously using onboard AI methods, and it will let us know how to prepare for the big events. And
Yeah.
when something happens, we'll be ready anyway. So that's the key.
Yeah, and I think it's interesting that you're using AI, something that we've been hearing over and over about in different applications. I guess how did you guys come up with the idea to take AI and apply it to bridge engineering, like how you're describing here? Was this something that took years to develop, or is this something that you're like, oh, we could use AI for that, and we should be using it to help prevent things that happened in Baltimore about a year ago?
So this process has been in the works since 2007, approximately. So there are many facets to the MIDAS system. There is the hardware component, and then there is the software component. So the hardware, we've been working on it since 2007, and the reason for that it took that long, is that the system has to be very cheap. We are talking about sensors that are less than $10 a piece, so you can deploy them in a very economical way. And also, they have to be self-powered, so they don't rely on batteries, and also they need to survive for extended periods. So these devices are built to sustain all the conditions and work for decades without any human intervention. And then comes the software aspect. So the software aspect, when we looked at what's out there as methods, computational methods that traditionally are used for this type of methods, they are very heavy, very cumbersome, and they take a long time and they're very expensive. So AI recently gave us a path that is more economical, that is a lot less cumbersome in terms of amount of work that we'll have to be able to achieve the same results as other traditional methods. So we started working with AI techniques for about 6 to 7 years now. And the advantage, obviously, they offer is the fact that they can autonomously learn. They can, by themselves, without human intervention, as they attach, they learn, and then they can predict what would happen in case of an extreme event.
Yeah.
So again, AI offer us a solution to replace previous numerical methods that are too heavy and too cumbersome to run for 600,000 bridges.
I'm curious to see if there are any cities currently using this, or is this something very new and you guys are just rolling this out, or are there actual cities and municipalities using the MIDAS system to help them keep track of their bridge health?
Actually, the proof of concept, the first installation that we have ever done was here. It was done in Michigan as a proof of concept, and it was done on the Mackinac Bridge as a very important structure, as you know, for the state. So that was our launching pad. We showed that it can work on a existing structure, an important structure like the Mackinac Bridge, and from there we were able to deploy it on many projects, including, and by the way, it works on everything. It works on bridges, it works on dams, it works on levees, it works on roads, turbine power plants, any structure that is subject to mechanical changes and mechanical loading that could lead to failure needs the same logic when it comes to monitoring, needs a system that can predict its future behavior. So we have deployed it on roads in Texas, in Florida, in Minnesota, and also in Europe, in France, in Belgium, and in the UK. We have deployed it on bridges here in Michigan, obviously, as I said, and we have deployed it on a couple of other bridges in Maryland, in Florida, and we have deployed it also on bridges in France.
Pretty interesting. Is there anything else I haven't asked you that you think is important to talk about when it relates to the MIDAS system? Again, really interesting technology that will, sounds like, help shape the future of bridge safety.
Exactly. So the other aspect probably that I'll try to mention is the economic or the return on investment for this technology. This technology is very cheap, very inexpensive in many ways, and it can save you from what we have seen. It can save between 30 to 40% on the cost of maintenance, and we are spending a lot of money on maintaining our infrastructure right now. And what we need is information to maintain it at the right time with the right method to extend its life in a good service condition for as much as possible. So what this technology allows us to do is to save a lot of money on useless maintenance. That's one thing. You know, when you're trying to maintain after the fact, when extensive damage has happened, that's usually very expensive. So what the technology allows you to do is to try to prevent that, to prevent the extensive damage and maintain at the right time to extend the life with minimal cost. So there is a huge return on investment and huge cost savings, obviously, for the communities, for the taxpayers, and for the country in general.